Hi, I'm Kirk Johnson with AdoredTV. Today we're going to be setting up a Ubiquiti airFiber 60 LR, which is a long-range point-to-point wireless bridge device. We have two of them, and we're going to unbox and show you what the setup looks like and take you through the UI on how to actually get those configured correctly. These are going to reside in a point-to-point bridge between two buildings on the same campus. And since that's not really a great example of what these long-range antennas can do, we're going to set up a bridge between my house and another house about 2 to 3 miles away, just to show you what it can do and the type of throughput you can get at that distance. Those kinds of setups would be great for remote site backup or just having file shares with friends or family. Now, Ubiquiti as a company has been around since about 2005. They started out making these wireless antenna products. They also have home automation tools such as this M-Fi M-Power 3-plug power strip that is individually switched so you can turn off each port over a Wi-Fi connection. They've stopped making these home automation things and have moved more into the enterprise environment with sector high gain antennas such as this one that you would use for a rocket. And we've been using power beam. These are the M5, but they have AC as well as some newer products as well, such as this airFiber device. These are carrier grade equipment, which means that they are used a lot by wireless ISPs to do residential service as well as long distance backhaul. They've been branching into things such as door access, solar power for their cameras and antennas, as well as they've been providing switches and edge routers and gateways. They have quite a few things. Go ahead and check them out on their website. So you might be asking yourself, why did we pick the airFiber 60 LR out of all the options we had? They have 5 gigahertz, 11 gigahertz, and these 60 gigahertz antennas for the airFiber series. Our area here is quite heavily saturated in 5 gigahertz as it is. We have several 5 gigahertz point-to-points already running, and they are suffering from a lot of noise. We get about -70 to -80 for our noise floor. So we went with these 60s because these have a high attenuation factor. The oxygen in the air absorbs the 60 gigahertz spectrum. It causes about a 15 dB attenuation per kilometer of distance. So these antennas compensate by providing a higher power signal, and we're able to get 12 kilometers out of this particular antenna. The 5 and 11 gigahertz antennas, they have ranges up to 100 kilometers or greater. You have the option to submit your data for your bridge that you set up to Ubiquiti's website to compete against other people to see who has the longest range. It's pretty cool. There's several in my area that have 15 kilometers or more with this particular antenna, even though it's only rated at 12. But we primarily picked it because the 60 gigahertz spectrum should be pretty quiet in our neck of the woods, as opposed to our very noisy 5 gigahertz band. The 11 would have been an option as well, but this is actually one of the cheaper devices in the lineup at MSRP of $399. So we've already got one. We're going to remove the other one from this box and get it set up. So to start, they've actually added a pull tab. Makes it really nice to open this box. And they've got an egg carton kind of setup in here. To help protect all of the internal components. We have our dish. And this is kind of a nice soft plastic. And this is a piece of foam, actually. So this is a sight that you can mount on the dish to help you aim at your remote location. And this just snaps right into one of these 3 points here. And you can use the sight in it to make sure that you're aimed in the proper direction. This is the horn, and this slots right into the bottom. And it uses this little thumb screw to tighten in to location into place. And you can run your Cat 5 or Cat 6 right up the horn here. And it comes up this channel, and you can plug it in right here. And it snaps together so it's nice and weatherproof. They provide a pair of supports. And these just hold the horn in place. So it's got a more stable base. And they just slide into place and lock like that. A couple of Allen wrenches. These are used to lock down the angles and to fine tune the tilt and azimuth. So the height and side to side. And these are lock washers and nuts all in one. And a safety screw or a security screw. So you attach this to the back, rotate and lock into place. And they have shapes denoting how it needs to be put in. You heard it click nice into place there. This is the bottom, and you can have this offset to the left or the right depending on the directionality and where your pole is. They actually sell poles that you can fix to surfaces such as a rooftop, and it has an adjuster so you can orient it vertically or horizontally. And this just goes in like this and locks down, and you can hold it in place very well. These are really beneficial, very useful to use, and it's really not that much money, so definitely recommend getting those. And the other 2 devices we got in here, we have the power cord and the PoE injector for this antenna. And if I'd stop dropping things. It has a little mount that you can put on a wall and then attach to your PoE device so that you can wall mount this or secure it near the antenna or in your server room. So let me show you this device here. It's actually very nice. It has markings here you can see for pitch and tilt. And especially nice are these. They're very fine-tuned adjustments for height and side to side. You can just tighten these down and slowly get it fine-tuned into the right spot once you've got the bulk of it set correctly. Once you've got this in place and everything is set up, you can put this security screw right in here. Use the small Allen wrench to get it locked into place. Let's go ahead and get this plugged in, and I'll show you how to get it set up. So once you have your PoE plugged in, there's one port for PoE. It's labeled in red, very well labeled. And then we have another port for LAN. This will go to your internet connection or your home network, your business network, and this will provide internet or network connectivity. And this side, your primary one, we set up as an access point, very similar to normal Wi-Fi access points. You can see this just feeds right through, no problem. Snaps right in. close it up, you can see on the side a little light. Not sure if you can see it from there. Lights up, showing you that it's setting up, initializing. It blinks for a little bit and then it goes solid. Since the airFiber 60LR is a carrier grade antenna, Ubiquiti provides a phone app called UISP, obviously for ISP use or internet service provider use. And this app is used to set up these antennas very easily over Bluetooth connection using your mobile phone. If you look under this little latch here, there's a QR code right here that you can use to set up the device, and it shows a 3-letter digit here of what device this is. And when you pull it up on your phone, you can either scan that QR code, or if it finds the device, you can just tap it to go ahead and set up the device. So we can go ahead and create a new device for the United States, and we can give it a name, set it in bridge mode. Its WAN IP we'll have as DHCP because we're going to plug it into our network, which has DHCP. So it says that our access point is now ready, and we can go ahead and do device detail. It gives us our IP address here locally, and we can now use a web interface to do the rest of the configuration, add a proper pre-shared key, set it up on the right Wi-Fi band and everything like that. So we pulled up our antenna's IP address in our web browser. The username is UBNT by default, and we have to go into our app where we configured it initially, go into the wrench, click on the system tab, and you have the password saved. You just click the show password and it shows you what the password for the device is, and we can go ahead and enter that. And you can change it in the app, or we can change it once we get into the web interface. This is what the web interface for a AP looks like, and there's no remote device attached at the moment. You can see we are currently Bluetooth connected and have that management off. Once we have configured the device and we no longer need to manage it anymore, we should go ahead and turn the Bluetooth off for security reasons. Let's go to the wireless. We can change our link name to whatever you would really like to have. We'll just choose Foxfire, and then we can set a new security key. The longer the better. Our country, United States, you'll change that for the region you're in. This is where you can set the IP address and the fallback IP. The fallback IP is if there is no DHCP address that it pulls, it falls back to the IP address and subnet that you specify here. You can use a static IP as well. If you're running VLANs, you can turn on the management VLAN so that you can separate your management interface from your actual network traffic. UNMS, this is the management service. This can be cloud provided, or you can host it locally. This is being renamed to UISP, same as the phone app. You can set up Ping Watchdog. With Ping Watchdog on, if your device fails to ping the IP that you specify after a specified interval with the startup delay, a certain number of failures will cause the device to automatically reboot in the event that it needs to reboot to reconnect. You can turn off the secure web server, the SSH server, and edit your authorized keys. You can turn up remote logging and specify your syslog server here. We have a firmware update available. We can just hit update now, and it'll go through the firmware update process. So let's go ahead and make sure we're on the current. Ubiquiti is really nice in that it provides the release notes for each firmware update. So you can see if any of the changes apply to your environment or if it will cause a negative issue in your environment. And it's always nice to know if there is anything that it adds, such as this where it fixes the MTU that was set incorrectly when you turn the management VLAN on. Just hit download. This is pretty safe to do over even unstable connections. I've updated many of these over a very unstable connection, and if it doesn't get the download properly, it just fails and you reboot it and it flushes the temporary download. If you're a big fan of uptime, these do take quite a while to do the update, so that is kind of a negative for it, but you're overriding firmware, so better safe. Now that our update is done, we can go ahead and log back in. Last couple of things we can configure is our time zone. We have our interface language. We can change the device name so we can readily identify our devices versus other devices that are out there. We can turn on the NTP client. Another nice feature for security is that you can change your administrator username. So you can change the UBNT to whatever phrase, word, name you want, which is always nice, so that now anyone that tries to break into the web UI has to guess both your username and your password. So I do recommend you change that. Now that we have our base station access point configured, we can set up our endpoint or our client device. And we want to do this here locally first, since we're doing a single point to a single point. There are sector antennas that are point to multi-point, and you can configure your base station here, your AP, and then just go out to locations and set up your remote devices that connect all to this one station. And that's fine as well. I like to set them up in the lab first, just to make sure that everything is working, that they are connecting. That way I don't have to be on site trying to set it up and wondering why it's not connecting. At least at this point, I'll know that it's because it's not pointing correctly, or there's interference, or some other reason why it's not connecting other than my configuration. Now that we have our client turned on, we could connect to it with the phone app once again, and it gives us the same configuration that we saw with the other. Set it up in bridge mode, DHCP for the IP. The interesting thing will be to see if it shares the pre-shared key automatically, because I'm setting up with the same phone. Okay. Now it wants us to aim the antenna at the access point. It's showing disconnected, probably because the pre-shared key is not correct. And from what I see on the UI, it is incorrect. You can go into the configuration settings and change your SSID and the pre-shared key so that they both match. As you can see from the chart here, we are now connected. We have a 1 gigabit link with total capacity of 1.66 gigabits and a link potential down in the 40% range because of our low signal. And if I just lift this antenna so that they're aiming directly at each other, you can see the instant jump in the receive and transmit signal strength. We're at 34, 36, because we're basically shouting across the room at each other now. You can see the full bandwidth available there. Now we're good to go. We can go ahead and take these on location, put one on my roof, put one at the remote site, and see what type of bandwidth we get. All right, now to find our target. There we go. So that's our target right there. We're going to be on that porch. All right, this is my roof. We got our temporary tripod set up here. Yes, it's a camera tripod, it's temporary. I got a lot of testing equipment here. You can see our power beam that we got going to a neighbor's house for some tests. And we have this lined up and sighted with the house that we're targeting. We'll just pull out our application here, turn on Bluetooth in location so we can see our airFiber here and get the IP address. And life hack tip for you, any pair of gloves can become a pair of smart gloves if you wear them for long enough. So we have an IP address on this, we have it aimed in the right direction. Let's go to the other side and get set up. Let's go ahead and sight this in. So we're going to pick out the neighbor's house, which is easy. And there's them, which would make this. It's kind of blurry, but that's our antenna right there. So we got a good line of sight right between the trees. If we were actually on the roof, it would be a little better. That's our target. All right, we have our PoE cable here. I'm just going to slide it in the horn, click it in place. There's a rubber grommet here to help keep the rain out. There we go. So we're going to go ahead and mount this to this support here and aim it. These have a nice feature that you can put band ties through here. I'm going to just use some zip ties since we're doing a temporary setup. But you can just attach these, it has some teeth here, and we're going to use a block since we're not going to use the proper mounting arm. We'll get this aimed. Now we just connect to it with the app and we can see how well it's aimed. So we're currently getting a minus 67 dBm. So we've got a good signal now. It's a little transient because the trees that we're aiming through kind of keep swaying in the breeze. So let's go ahead and give this a speed test real quick before we lose signal again. Obviously, if we were going to set this up more permanently, we'd put a mast on the roof and it would be 100% solid. There's actually a peak right behind the camera here where I have attached one of these before, just a weaker version of this. So let's see how much better this one does versus the old antenna that I used to run. Just updating the firmware. So we can see in our web interface here that we're at about minus 57, minus 59. It thinks our capacity is 1.7 gigabit. We're currently under our recommended signal level based on our distance and some of the calculations that Ubiquiti likes to make. We're just shy of 3 kilometers. We're at our baseline here. So we'll go ahead and run a speed test. Now that's pretty impressive. We're at 640 MIP on our download. Our internet connection that we're connecting to is only about 850 on a slow night where not very many people are online. Now we got a upload of 660 MIP. So we're pretty much getting all but maybe 10% of our internet traffic potential right here. You can see our speed test one way. Now we can check with the speed test that is provided by Ubiquiti, and we're going to do a duplex test. So this is both ways simultaneously from antenna to antenna. And you can see it's most likely our internet connection that was holding us back on that previous speed test, because we're getting a full 820 megabit, which is about half of what this is really rated for. But that's really not that bad considering we're at a minus 59 dBm instead of the expected minus 45 dBm. For zip tying an antenna to a pole and setting up the other one on a camera mount on a roof, we're doing really well. High speeds both ways and a total aggregate of 1677 MIP. So right where we expect it. And I mean, look at this, guys. We're zip tying this thing to a wall. Now this is very finicky in having to adjust it side to side. Once you get it dialed in though, it'll be great. So it's really that easy to get these set up and get a pretty substantial bridge even over a pretty big distance. We're gonna have way better connectivity than you saw in our little demo because we're shooting about 100 yards across the parking lot in our final configuration for this. So I think we're gonna be more than happy. So one thing to keep in mind is that these 60LRs, they only support 150K packets per second. The more expensive, higher end airFiber devices support anywhere from 1 to 2 million packets per second. So you can get a substantial increase in throughput as far as individual packets are concerned just by stepping up to some of the more expensive but higher quality products for that. These are meant more for maybe 60 devices in a small network to remotely connect to another network. So perfect for home use, especially for home connectivity back to a ISP. So this solution is going to work very well for us. We were considering running a physical connection, such as a fiber optic line, but these came in so much cheaper than to run that physical line, and they will serve the purpose very well with the low latency that they provide. We've been very happy with the antennas we purchased to this point. These will be our first upgrades to the airFiber devices. We've been primarily running power beams to this point, so this will be a great proof of concept to see if we need to upgrade other devices in our environment to take advantage of the higher throughput and better connectivity that these provide. So I'll be reporting back on that later. So stay tuned, be sure to like and subscribe, and we'll see you in the next one.